Okay, for this part, we're going to do another partial fraction decomposition. This is a more complex problem here. Again, following the steps as before, this kind of follows the same format, in that what you'll want to do again is you want to have that denominator fully factored. I'm not going to go into how we do that. I'm just simply going to write the solution. If you're curious how, I would use grouping in this case. So that would be x squared minus 3 times x plus 2. Recall that every single factor gets its own fraction, so there you are. And each numerator is going to be 1 degree less than the denominator. So here the degree is 2, which means the degree on top is going to be 1. Here the degree is 1, and that means we're just going to have a constant up on top. So we have ax plus b, and we just have c. So now that we have that, let's go ahead and figure out what a, b, and c are. Here I've written out the whole statement. What you're going to do here is you're going to multiply out the denominator first, and if you're looking for guidance on what to write, use this as your guide. You'll multiply both sides by that. Now in doing so, what will happen is this. These two here will reduce out, as do these two. And that's kind of the idea. We don't want a fraction in this case. That's the only reason why you would multiply out the denominator. This group here would distribute to here and here. So what will happen is the x squared minus 3 will go away here. The x plus 2 will go away there. And once you've distributed, you should get something like this. What you're seeing here in green is the result of the distribution here. What you're seeing in purple is the result of the distribution here. So what happens essentially for this first fraction, what happens is that these two just reduce out, and what you're left with is ax plus b foiling with x plus 2. So that's what you're seeing here as the result in green. For the distribution on this second fraction, you're getting this whole thing here, this x squared minus 3x plus 2 being multiplied to this, and the x plus 2's reduce out. Again, if you do this right, the denominators do reduce away, and you're left with just terms here without the denominator being anything other than 1. Take your c and distribute, you get c times x squared and c times 3. Okay, now let's go ahead and take the like terms, and we're going to be collecting these like terms together according to powers of x. So hopefully you recognize that these two here are x squared. They go together, and these two here are just x. They go together, and that leaves you with the ones without any variables, rather powers of x I should say, and that is the 2b and the negative 3c. So what you wind up with is this. You get a plus c quantity x squared. You get 2a plus b quantity times x plus 2b minus 3c. Again, these are grouped together according to powers of x. So you're seeing the a x squared and the c x squared here, so a plus c. For 2a plus b, that's the bx. There's the 2a right there, and both have just x. And what I've done is simply just factored out the x's there. Same thing here for the 3c and the 2b. That's just simply grouped together. Now, on the left-hand side, I rewrote negative 3x and positive 29, but I've also included a 0x squared. And if you're wondering why I'm tacking this in, it's because there's an x squared here. So I want a term on the left-hand side to match what we have here. So you should see this as 0x squared. This is negative 3x, and this red one as 29. Alright, now that we've gone ahead and collected those terms together, let's go ahead and create a system for this. What we'll do is, using those powers of x, we'll set those coefficients equal to one another. So hopefully you should recognize is that with the x squared, that's going to match this entire part here, a plus c x squared. This is just x. That matches this one with just x, and this is just a constant, so that's going to match this, which does not have an x. Therefore, this is what you are left with. If you're wondering where the x's went, like shouldn't this be 0x squared here on the left, and shouldn't this be a plus c x squared here on the right, just as it is here? Sure, you'd be fine in doing that, but keep in mind that you can just simply divide it out. If you divide this term by x squared and this whole thing by x squared, well, there's no more x's. Same thing here on this second formula here with just plain x. They divide out, so there is really no need to write them. If you're wondering about the spacing, I'm just simply aligning all the variables a's, b's, c's. So now that we have this system, we can go ahead and solve it using elimination or substitution, however you wish to do it. Assuming you can do it, how about we just go ahead and skip to it. So we got A is negative 35, B is 67, and C is 35. Once you've gotten that, just simply rewrite that into your original formula, in that here for A you'll write negative 35, and for B you'll write 67, and for C you'll write simply 35, and that would complete your problem right there. Don't forget to do that. A lot of students will end up just simply being satisfied with getting A, B, and C. So just simply write that back in to establish that you have written the entire decomposition as two fractions. And that's essentially it. That's it for this one. I'll see you next time.